Today I am going to give you an idea about the 3-bit up-down counter. In the last class, I have told you about the 3-bit up counter and 3-bit down counter. And all these are under the asynchronous counter. Asynchronous counter. So last class I have told you about the 3-bit up counter, asynchronous, and 3-bit asynchronous down counter. Now I am going to tell you about the 3-bit up-down counter, a single counter that can be worked as a up counter as well as down counter. These asynchronous counters are also called ripple counter. Ripple counter. Why it is called ripple counter? Because in asynchronous counter we are providing input to a single flip-flop, that is the first flip-flop or LSB, and after that in every steps output of the previous step is given to the clock input of the next step. So that is like a ripple. Whenever we are throwing one object in a water body, so at the center position wherever we have thrown this particle or body, that water body, one wave is created in the water body, and one single wave, first one single wave is generated, and single wave creates the next wave creates the next wave. So by this way, if I throwing one body into a water body, we can observe one wave is propagating from the center to the outside. So if I imagine that in asynchronous counter, in case of asynchronous counter, so we have given clock to the first flip flop, and after that the output of the first flip flop is given to the clock of the next flip flop. So here is clock is not provided to individually all flip flop. Clock is provided in a single flip flop, and that clock creates the whole flip flop clocked as in a sequence. That is the asynchronous type. So in asynchronous counter, basically we have seen that for up counter and down counter, I have given you 4 cases here. For negative edge triggering, that I have also discussed in the last class, that is the for negative edge triggering flip flop. If the clock is considered from the queue, that will create the up counter. If we consider a negative edge triggered flip flop, as well as clock can be derived from the Q complement, then this counter will be act as a down counter. As well as if we consider the positive edge trigger flip flop, so that the same thing down counter will be created for positive edge triggering. So down counter will be created by positive edge triggering flip flop with Q complement is taken from clock is considered from the Q complement, and as well as same up counter can be created by positive edge triggering flip flop with clock is taken from the Q. So this is a basic arrangement by which we can convert one flip flop to the one counter, can maybe acts as an up counter or down counter. So that is a separate circuit arrangement. That is either one counter should work as a up counter or down counter. But in case of up-down counter, a single counter, we should design one single counter. That single counter is acts as a up counter as well as down counter. So in this case, we need a mode control. Basically, mode control input that can be signified by capital N is used to select up or down. Just example, if I can consider as m equals to 0, whenever we consider m equals to 0, that the counter will work as a up counter. when we give the input to the M is 1, the counter will be acts as a down counter. Down counter. So a single counter can be acts as a up counter or down counter by giving a single input to the single external input to this counter. So basically it is a asynchronous counter. Clock is given to the first flip-flop. But here this mode control input is connected with a combinational logic. That we need to design this combinational logic, so that combinational logic is driving the circuit, or combinational logic controls the circuit to work as a up or down. So I can draw the block diagram of combinational logic. So this combinational logic is connected with the output, that is a Q and Q complement, and it has one another input, that is M, and final output is a Y. So based on this we can formulate one truth table for based on this with this M and Q complement. So M is basically two type of values, 1 0 and 1. So I am segregating M with the Q and Q complement and giving Y. So when this both Q and Q complement, so 2 bit numbers, so 2 bit number 4 arrangements can be possible, 4 combinations, 0 0 0 1 1 0 1 1. So 4 combinations are possible, but here M values are 2, so M can be 0 for these 4 combinations, M can be 1 for these 4 combinations. So for this 0, the counter will act as the up counter, and for this counter will work as a down counter. Now when we consider this counter is a negative edge trigger, if we can consider the counter is a positive edge trigger or negative edge trigger. If we consider that the counter is a negative edge trigger, for creating up counter, we should consider the output from the Q, that is here. Whenever we consider the negative edge triggering, for up counter we should take the output from Q, and for negative edge triggering, for down counter we should consider the output from clock from Q complement, and for up counter clock from Q. So here for up counter we should consider this output Y should be same as the Q, and for down counter Q complement. Now this we have formed the truth table. From here we can get the logical expression of Y. So how can we get the logical expression of Y? By using the K-map. Here 8 variables are there, so I can write the 8 variable K-map. So here MSB, M and Q complement. So 0 0 0 1 1 1 1 0 and 0 1. So 0 0 1 1 0 1 0 1. So now from here we can group this. So here we can formulate the Y equals to M complement Q, and here it is the M Q complement. Now here 3 gates are there. We can see that 3 gates can conduct this logical expression. So one is here is the AND gate, here is also AND gate, and one OR gate. So 3 gates for logical combination or logical circuit, we need 3 gates to give the clock pulse. Now I can draw the main circuit of this 3-bit up-down counter. So for this I need 3 flip-flop, and for this purpose I can consider the T flip-flop, 3 T flip-flop for this. Now I can give, I can consider this, this is FF0, FF1, FF2. So here is a Q T0, Q0, Q0 complement, T1, Q1, Q1 complement, and here is a Q2, Q2 complement, and T2. So for this I can give the same input, logical 1 to the T. Logical 1, and I can consider one another input, that is the M and M complement. So for this I can take the one logical 1, another logical 1, and that is the M. So one is the M, another should be, I will add one NOT gate with this, and this is also M complement. One is the M, another is the M complement. Now I can place the clock. Negative is triggered. So here I should place 3 gates. Also here also I can place 3 gates. So when it is I should connect this. When Q is connected, so M complement is connected. Q is connected with the M complement, and here is the M is connected with this, and I can take the output from this Q0. Here also same thing, M complement is connected with this, and M is connected, and Q1, here Q2. So here it is Q naught M complement, and here it is Q naught complement M. So addition of this can provide as a clock of the next level. And same here as Q1 M complement and Q1 complement M. Addition of this is provided to the clock to the next level. So this one is the LSB, this one is the MSB. Now if I provide the logical 1 to say I am providing 0 to the M, 0 to the M, but here I can I am erasing this, I am providing M is equals to 0. So M complement should be 1 and M equals to 0. So any of the input of AND gate is 0, so output is 0. So for this one is 0, but this one is Q complement. This one is Q complement. So next clock of the next level is got from the Q complement, Q naught. And here it is when here it is also the same like that. Q1 is provided to the clock of the next level. So if I am providing here not 0, here 1. So Q M complement should be 0. So here it is 0, but it is the Q not complement. So clock of the next level is got that Q not complement. So by this way, so when negative edge triggered flip flop is provided, negative edge triggered is flip flop considered, and clock is taken from the Q. When negative edge trigger and clock is taken from the Q, the counter basically acts as a up counter. That is a table I have provided here. When negative edge triggering and clock is considered from the Q, that is the up counter. So when M equals to 0, here it is the clock of the next level is got from the Q0 and clock of the Q1. So that now this whenever we are giving the 0 to the M, the counter is acts as a up counter. M equals to 0, that is up counter. When we are providing M equals to 1, that means here M equals to 1 and M complement equals to 0. So M equals to 1, that means this one is 0, M complement into Q naught is 0. So here we can get the output, that is a clock of this can consider this Q naught complement, Q1 complement. So when negative edge trigger and output clock taken from the Q naught complement, that is a down counter. So this counter acts as a up counter and down counter. When M equals to 1, it can act as a down counter. That is, we are considering the clock from the Q naught complement, Q1 complement, that is a down counter. So when M equals to that, we have decided earlier that when M equals to 0, we should design the circuit as a up counter. And M equals to 1, the circuit can be acts as a down counter. So this one is the circuit of 3-bit up down counter. So LSB is considered from the Q0 and MSB is considered from the Q2.